Example 1.10. For each integer n, define b of n to be the set consisting just of n if n is odd, and the set consisting of n minus 1, n, and n plus 1 if n is even. And the collection B consisting of all such b of n is a basis for topology on the integers. The resulting topology is called the digital line topology, and we refer to Z with this topology as the digital line. I've attempted to draw this basis down below. You see that when n is odd, we have, for example, b of negative 3 containing just negative 3, b of negative 1, b of 1, b of 3, and so on. And when n is even, for example, b of negative 2, we have b of n containing the even integer itself together with its two odd neighbors. So there's b of negative 2, b of 0, b of 2, and so on. So let's do exercise 1.14. Let B be a collection of subsets of Z used in defining the digital line in example 1.10. Show that B is a basis for a topology on Z. Okay, well, we have to check the two properties of a basis. For the first one, we can say for any n in the integers, well, n is always in the basis element B of n, right, whether n is odd or even. So that takes care of that. And then for the second property, well, we should consider the cases when n is even and odd separately. So first we can say if n is even, then any basis elements b1 and b2 containing n, well, they must both equal b of n, right? Because if you look at any of the even integers up here, b of n is the only basis element containing n, right? So they're both equal to some b of n. Therefore, we can just take b3 to also be b of n, right? It still contains n, and it's contained in the intersection of b1 and b2. So that case is relatively simple. Let's think finally about the case when n is odd. Right. So if n is odd, then, well, let's copy all this. Then any b1 and b2 in the basis, both containing n, also must contain, b of n, which, since n is odd, is just the singleton set. Right. So we have the sort of thing we want, namely b of n, which is our b3 here, contains n, and is a subset of both b1 and b2. And that does it. That shows that B is a basis of a topology.